All right, so we're going to build a playground, and we have some volunteers. The time T in hours that it takes a group of volunteers to build a playground is going to vary inversely with the number of people that are helping. And we know 1 point on this inverse. We know that it takes a group of 10 volunteers 8 hours to build the playground. So we're going to go through the same steps that we just did on writing an inverse equation and solving it. So we can write an equation showing how the time changes as the number of volunteers changes and solve that for A so that we know what A is equal to. So we're used to using X's and Y's. We have Y is equal to A over X, or A is equal to X times Y. However, in this particular example, we are using T and N, the number N for number of volunteers. So our X value is N, our Y value is going to be substituted with T. So let's go ahead and rewrite this in the form that we need for this real world problem. X and Y actually have meaning now. They are time and number of volunteers. So we can say that time varies inversely with the number of volunteers. The more volunteers you have, the less time it's going to take. Or the other thing we can say is that our constant is equal to the time times the number of volunteers. All right, so let's go ahead and solve for A. That was the second part. So this is our equation right here. But we want to know what A is. So we can say that A is equal to T times N and plug in the values that we know. We know that it takes 8 hours when we have 10 volunteers. So our coefficient of variation, A, is equal to 80. That's our constant. All right, so if we wanted to write our final equation, T is equal to 80 over N. Just like that. All right, so we've written our equation in generic form, we've written it in specific form with the 80. Now we want to create a table here that shows us how the time changes as we add more volunteers. So again, we are just evaluating the equation we just came up with, that T is equal to 80 over N, and we're evaluating it for specific values of N. So the first value is already given for us, that when we have 10 volunteers, it takes 8 hours. But now we want to find out what happens at other values. So when we have an N value, a number of volunteers, equal to 15, it's only going to take 5.3 hours. And that 3 is repeating if you stick that in your calculator. So I'll go ahead and note that. Whenever we have 20 people working on it, it only takes 4. When we have 25 people, see, over 25, then that is 3.2. And finally, the last value we need is 30, and that's going to give us 2.666 repeating. So let's go ahead and transfer those numbers to our graph. And that answers B. All right, so you can see that the time starts going down as the number of volunteers goes up. All right, so now we just want to kind of describe in words what happens to the time that it takes when the number of volunteers increases. Well, looking at the table, we can see, or we actually could have even indicated it at the very beginning because we knew that it was inverse variation. We were told that in the problem statement, that the time required to build the playground So the time required to build the playground decreases as the volunteers, try that again, as the volunteers increases. All right, so inverse variation tells us that as one value goes up, the other one must go down. This concludes our lesson. Thanks for watching.